Okay, given this setup, we want to find the mass of the block. Okay, we know the unstretched length of spring AB. We know the spring constants. It's got this position. Let's go ahead and get started. We'll start by drawing a free body diagram of point A because everything is concurrent at point A. So we'll draw that free body diagram. Okay, so I've got a tension in the cable going downward. We'll talk about that in a second. Okay, I've got force in this spring going up here. I'll call this FAC, and I'll notice that it's 3 meters by 3 meters. So this is a 45-degree angle. Okay, and then over on this side, I have FAB, and this is a 3, 4, 5 triangle shown like that. Okay, so let's talk a little bit about the tension going downwards. Now I drew it as tension. Moving forward, we will just say it's the weight of the object. But officially, I have a free body diagram of the body that I'm dealing with, the block that I've got there, and that block has a weight given by mass times gravity. Okay, and then there's the tension pulling back up. Now that tension is the same tension that I've got in my original free body diagram. Okay, so very simply, I can sum the forces in the y direction and see that that tension equals mg. Okay, and in the future, we would just call that mg there. Okay, and keep in mind, m is what we're looking for. G is 9.8 meters per second squared. So I'll just call that 9.8 m. Okay, now finishing going through my free body diagram, there's a few other things that I know. Again, I know the unstretched length of spring AB is 3 meters. Therefore, I know the force in this spring right here, which again is going to be K times S, where K is the spring constant of 30 and S is the stretch in the spring. Now, this spring is 5 meters long because again, it's a 3, 4, 5 triangle, right? So the length is 5 and the unstretched length is 3. Okay, so the total stretch is 2 times that spring constant of 30, so this becomes 60. Okay, so I know that force. The two unknowns in this are the spring force FAC and the mass that I'm looking for, M. Now, fortunately, I'm going to have two equations to solve that, and those equations for equilibrium, which this is in, is the sum of the forces in the x equals 0 and the sum of the forces in the y direction equals 0. So I'm going to use my free body diagram that I drew here to figure out what the force is in the x direction. So we'll start with my known force of 60. In the horizontal that I'm interested in, that relates to the 4, so that's going to be 4/5 times 60. Okay. The other force that I have in the x direction is my unknown FAC, so I'll say minus FAC sine 45. Those are my horizontal components of my forces here, right? The weight acts vertically, so it does not show up in the x equation. So I go ahead and set these equal to 0 because there is no acceleration. It's an equilibrium, so the sum of all these forces equals 0. So those are my horizontal forces that I've got. Now on the vertical forces, start with my known force. This time it's going to be 3/5 60, and it's acting upward, so it's positive, plus FAC cosine 45 acting upward, and then I've got my minus 9.8 times the mass acting down. Those are all my vertical forces. And again, this is an equilibrium, so these also equal 0. Okay? So now all I do here is I sum the, I figure these out. Okay? So in that top equation, I can go ahead and solve FAC, and I find that to be 67.9. I take that, plug it into the y equation. It's just two equations, two unknowns, and I can solve that m equals 8.57. So again, draw a free body diagram where you put all the directions, everything you know about the forces, angles, magnitudes, things of that nature. Once you have that drawn, then it's very easy to sum the forces in the horizontal x direction, sum the forces in the horizontal y direction, set them equal to 0, and then solve up to two unknowns, looking for the answer that we get.